Okay, I think we are live. I hope I am audible. Thanks everyone for joining in. So today's session is on functions. So before we start, I would just like to say follow us on WhatsApp. I'm pretty sure many of you have already joined the WhatsApp channel. We keep posting links and we keep answering your queries there. So do follow us. The link is in the description below. Let's move ahead. Okay. If you are not attempting these mocks, just go to cracku.in/IIM Bangalore UG mock test to take these mocks. You should finish these mocks. They are very beneficial for you, and you should expect that these are pretty relevant. Although we cannot be sure because we do not know the exact syllabus, but these are very relevant. If you are scoring good in these, you can be sure that that they are a good sign that you will score in the actual exam as well. So let's go ahead. So here is our class schedule. Today is 10th November, Monday. We are doing a class on functions, and this is the this week's schedule, basically till the next Monday. There's a webinar on 16th of November, so do join us there. Let's move ahead. So talking about function, let's start with Cartesian products. So consider sets. We all know what sets is. Sets are a group of objects, a group of elements, a collection of elements that is well defined. So the elements must be well defined, and that is referred to as sets. When we are talking about Cartesian products, we are essentially referring to two sets. So we need two sets. Let's say A and B. A has that's elements 1, 2, 3. B has the elements say A, B, C. The Cartesian product takes each element from A and it tries to create an element. It tries to create an element from here. One element will be taken from A, one will be taken from B. So let's say we will take C. So this sort of pair of elements 1C, 2B or 3A, the set of all such pairs is referred to as a Cartesian product. So the set of all such pairs is referred to as the Cartesian product. So Cartesian product of A cross B, which is A and B, the Cartesian product of A and B is the set or is the element A comma B inside brackets such that A belongs to A and B belongs to B. You can also write it like B cross A, which is the Cartesian product of B and A. This will be BA such that B belongs to the set B and A belongs to the set A. What is important to note is that B cross A need not be the same as A cross B, because remember, when A and B are different sets, they are not equal to each other. Then the first if you do A cross B, then the first element will be a number because A has numbers. The second one will be an alphabet because B has alphabet. Instead, if you do B cross A, then the first element will be an alphabet, the second will be a number. So it's different. A cross B is different from B cross A if A and B are different sets. If they are the same sets, then that's a different story. But I hope you understand what Cartesian product is. So taking any two sets whatsoever, assigning sort of a relationship between them, or not assigning the relationship between them, but taking an element from each, pairing them up, that is referred to as the Cartesian product. Relations are a subset of Cartesian product. What is a subset? Any subset, you can define it in any way you want. You can just take one set A, you can take another set B, you can define a relation any which way you want. So consider the sets that we had earlier. We had 1, 2, 3 and we had B equals ABC. Now if I want to define a set where so alphabetical order, whatever comes first and numerical order, whatever comes first, they will be paired. So 1 will be paired with A, 2 will be paired with B, and 3 will be paired with C, and that's it. That's my way of defining a particular relation. It doesn't matter what relation I want to define it as. Another one can be, I want to define a set where 2 only is paired with A, B and C, and 1 and 3 are left vacant. They are not paired with anything. That's also a relation. So I need to define a relation. So again, if you consider the elements that will come inside relation, there will be a subset of the Cartesian product set, because the Cartesian product set will have all the possibilities. It will consider every possible element from A. It will pair it up with every possible element from B. But relation are a subset of it. It doesn't matter how you want to define it. The definition can be very finite, or you can write essentially it in a roster form. You can write each and every product, the element which is inside the brackets individually without actually having a definition for it, right? So that's one way. But essentially now you understand that what a relation is and what a Cartesian product is. I think we can move on to discussing what a function is. So before moving on, let's just discuss, let me just see if there are any doubts. So I don't think there are any doubts. What is a function? A function f from a non-empty set A to a non-empty set B is a special kind of relation between A and B, such that every element of A is associated with exactly one element of B. So function is a specific kind of relation. Now we discussed that Cartesian product considers all the possibilities. Here then we discussed relations. What are relations? Relations consider a subset of those possibilities, some of those possibilities, not all of those possibilities. What is a function? Function is a type of relation, because function is also a subset of Cartesian product, but the condition is that each and every element in the first set, which is the input set, will map to only one element in the output set. There cannot be more than one element that the input set maps onto. So therefore, every element of A is associated with exactly one element of B. That is what the definition of a function is. In other words, a function is a subset of the Cartesian product A cross B, in which no two different order pairs have the same first element. So the same first element should not be the same. The input, when it comes to graphs, when it comes to polynomials, we define it as the input, the variable, the x variable. The x variable should have only one output. When we put some value of x inside a particular expression for a function, the output that comes out should only be one output. There cannot be more than one output. That is known as a function. We write it as f, a function such that A to B. F is defined on A to B. So f is taking input from the set A and output are taken from B. And for each A, an element A in A, the corresponding B, an element B in B, is called the image of A under F. So this output is also known as image, written as f of A is equal to B. So f of A, the A input A, when we put it inside the function, the output or the image comes out to be B. Let's now discuss domain, codomain and range. So what exactly is a domain and what exactly is a codomain? So domain is the set of all inputs permitted by the function. So again, there are some functions, they can take some values. All the values that they can take inside of them, that is referred to as the domain. You can also think of it as the set A, right? We discussed the set A here, this mapping from A to B. This set A can be thought of as the domain, but the set A might sort of have some elements that are not allowed by the function. So we will remove those elements, and then the new set that will be considered, that is considered as domain. So this domain is the set of all elements inside that the input can take. So some elements the values cannot be taken, other elements that values can be taken. The values that can be taken by the input or the A in A, these values are referred to as the set of these values is referred to as the domain. What is codomain? Codomain is the intended set of outputs. So codomain is equal to B. Domain is some part of A, right? It need not be totally A, because A might have some numbers that are not permitted by the input, but the codomain will always be B. But if you think about it, the function, when you put some input inside it, there are some outputs that can be taken, there are some outputs that cannot be taken. So the outputs that can be taken, the set of all those outputs is referred to as range. So the range is a subset of codomain, right? Range is all the outputs that are actually realized, outputs that can be taken by the function. The codomain is the set of outputs that we allow the function to take, right? Beyond which we don't allow the function to, even if it can take, we don't allow it to take. So codomain is the intentional set. It depends on the context. We decide what the codomain is. But when we talk about range is what the function wants to take among those set of outputs. And domain, of course, is a subset of the set A, a subset of the set of inputs that we are trying to give to the function, that the function is accepting as inputs. So consider these examples. The first example is fx equals square root of x minus 3. We understand that whenever something, some expression comes inside the square root, the expression has to be greater than or equal to 0. It cannot be less than 0. Otherwise, it won't be defined. If we are to define the function, square root function, the expression that comes inside the square root function has to be positive or greater than 0. Positive or equal to 0. So x minus 3 is greater than or equal to 0. This means x is greater than or equal to x is greater than or equal to 3. So if x is less than 3, this function will not be defined. So you can say that, okay, I will allow fx, I will allow x, which is the input, to take any real number value. So I'll allow it, but it will not take any real number value. It will only take the values that are greater than or equal to 3. Since it will only take the values that are greater than or equal to 3, we say that the domain of this function is all the values greater than or equal to 3. And if you think about it, when you put anything inside the square root, what comes out is any positive number. So it will, if you put it equal to 3, then it will be square root inside x minus 3, which is 3 minus 3, which is 0. So square root of 0, we will start with 0. The square root of 0 is nothing but 0. Then we will go for 4. So 4 minus 3 is the square root of 1, and then it will come out as 1. So 0, 1, 2, the square roots will keep going on. So the range, although you can define the codomain to again all be real numbers, but the range will only be all the positive numbers. Then comes another function we have, 1 over x square minus 4. Now we know another restriction when it comes to functions like this. The denominator can never be equal to 0. Why? Because if the denominator is equal to 0, the function is not defined at that point. So x square minus 4 is equal to 0, gives x square is equal to 4. Now if x square is equal to 4, then what can x be? X can be 2 or x can be minus 2. If x is taking these values, then at these points the denominator will become 0 and this function will not be defined. And therefore it is important that whenever we have some number, some expression in the denominator, we make sure that the denominator is not equal to 0. And therefore this function can take any real number inputs except x is equal to plus minus 2. So at plus minus 2, the function will have gaps. There will be no definition there. And at all the other places, the function will have some defined value. Then comes fx is equal to the natural log of x plus 2. So natural log of x plus 2, we know that if x plus 2 is essentially the argument of the function, right? So x plus 2 is the argument of the function. Argument can never be negative. Argument can never be 0. So argument has to be positive. We know that. So therefore x plus 2 is greater than 0. If x plus 2 is greater than 0, then x is greater than minus 2. So if x is less than minus 2, the function will not be defined. So the domain is nothing but x is greater than minus 2. Domain is all the real numbers such that x is greater than minus 2. We are not considering x is less than 2. So I hope you understood what domain is, what codomain is, and what is a range. Let's move ahead to the next one. Let me check if you have any doubts. Okay. So let's look at graphs and transformations. say we notate a function such as fx. So f of x, an input x is provided, function f is defined as the input, the function of that input. Now if we are to shift the graph vertically, right, let me first give you an example. So consider, let me erase this. Consider the equation x square minus 12x plus 7. So what are the roots of this equation? We can apply the quadratic formula. We will get 12 plus minus 12 squared, which is 144, minus 7 for the 28. This will give us square root of 6, 14, 13, minus 2 is 11. Let me choose some other equation so that we have a good amount of zeros, right? We need good zeros. So that is 144. We need plus 25. So let's choose 25 by 4. So if we calculate the roots of this equation, what will come out? This will be 12 plus minus b square, which is 144, minus 4ac will be nothing but 25 divided by 2. This will be 12 plus minus root 169 will be 13 divided by 2. This will be minus 1 over 2, or 12 plus 13 is 25 divided by 2. So these are the roots of this quadratic. This can be written as minus 0.5. This can be written as 12.5. So if you sort of plot this equation, plot this quadratic equation on the graph, what will the graph look like? The graph will look like something like this. So let me draw it here. So this is the x-axis, this is the y-axis, and let me choose a different stroke. Okay, so here we have minus 0.5 somewhere over here, then we have 12.5 somewhere over here. It is a quadratic equation. The coefficient of x square is positive, so quadratic equation will look something like this. This is how the quadratic equation will look like. Now if you are looking at any graph of this function, so for example the function fx is plotted on y, so this is fx and this is the input x. Now if you want to sort of move this graph here or up or down, wherever you want to move it, and these are some sort of transformation rules that you can look at. The first look is at vertical shift. So if you want to move the graph up by k units, you will just add fx, k to fx. If you move the graph down by k units, you will just subtract k from fx. Similarly, if you want to move the graph horizontally, which is like this or this, if you want to move the graph like that, then you can subtract h, which is the horizontal amount of like you want to move. If you want to move the x units by 5 units, say the x-axis parallel to x-axis by 5 units, if you want to do that, then you can just subtract x minus 5 and you can take the function of that. If you want to do it the other way, you can subtract minus h, which just means that you can add h and calculate the function for that. So that's one way we can do horizontal shift. Then comes reflection in x-axis. So this is the x-axis. If there is a graph like that, and if you want to reflect it downwards, if you want to reflect it so that it comes downwards, you can just take the negative of the whole output. So whatever the output is, what is the output? The output is fx. You can take the negative of it, the graph will be inverted or mirrored against the x-axis. Then comes the reflection in y-axis. How do you take the reflection in y-axis? So say this is the y-axis. If you have this new graph, if you want to sort of reflect it against the y-axis, this will look like this, right? So if you want to do this, then you can just take the negative of x. What this will do is that all the negative y-axis will essentially act as the positive x-axis. The negative x-axis will act as the positive x-axis. The positive x-axis will act as the negative x-axis. So all the inputs will shift. So essentially you are totally rotating the graph by 360 degrees. And whatever comes in front of you is the 2D image that you get from that. So this is what we do if we want to sort of reflect a graph against the y-axis. E times fx vertical stretch. If you want to stretch the graph vertically, so currently say if the graph looks like this, if you want to stretch it vertically, so that it becomes much more skewed like this. If you want to skew it, then you can multiply it by a, the whole output by a. If you multiply the whole output by a, it will get slightly skewed. You will get a graph like this. And if you want to compress it horizontally, so for example, if this is the original graph, if you want to sort of compress it like this so that it becomes slightly broader, then you can sort of multiply a constant by the input itself. So these are some of the transformation that we are taking a look at. For more, you can try it on Desmos or some graphical calculator. You can put a random equation as the definition of fx, then you can do all these playfully some operations on input or the whole output, and based on that you can see how the whole sort of graph transforms, and that will be very enjoyable, right? And it is a learning experience as well. Character of a function. Now the way the function presents itself, let me check your doubts. So the way a function presents itself, there are many ways a function can present itself, right? So we understood that a function has one input. For one input there is only one output. The output can be common between multiple inputs, but one input will only have one output, and that is the restriction that a function has. So consider, for example, a circle. A circle is not a function. Why is circle not a function? So if you take this input, there is this output right here, and there is this output right here. So circle is not a function because for one input, which is one value of x, there are two outputs, one above and one below, and that becomes a problem because that does not satisfy the definition of a function. On the other hand, if you look up at a parabola that we just looked at for a quadratic equation, there is only one output for one input. Although if you look at the horizontal line here, for this value as well as this value, the output are the same, but that is not really our concern. We don't really care about output being the same for two different inputs. What is an issue is that for one input there should not be more than one output, right? So there are many ways to define the character of a function. How many different types of function are there? The first is 1 1 versus many 1. So 1 1 is a function, horizontal line intersect at most once, implies 1 1. So like we just discussed, consider a parabola. So for parabola, what happens is that for this input and this input, say this is the output here, this is the output here. If you see, the output are the same for two different values. Although it is a function, the output are the same for two different inputs. This is considered as 1 1. Horizontal like this is considered as many 1. So many inputs are mapping onto a single output. If this is not the case, if outputs are distinct for each and every input, if outputs are distinct for each and every input, then that function becomes a 1 1 function. So this is the essential distinction between a 1 1 function versus a many 1 function. Then comes onto versus into. So if range is equal to codomain, it implies onto. So we just discussed what a codomain is, right? We discussed that if f is defined as a function from the set A to the set B. If we are defining a function f from the set A to the set B, there are some number of inputs that we are giving from set A. That is not our concern, that we don't care about. Currently we are looking at B. So we I told you that, say, consider this is the set A, this is the set B, and let me enlarge this, right? So this is the set A, this is the set B. There are many elements here, there are many elements here. So if each has a different sort of value, no, not that, say this. Now this is a sort of into function. Why? Because each input has an output in B, but there are some outputs, there are some elements in B that are not outputs of any input. In this sense, this becomes the range, this becomes the codomain minus the range. So codomain, that there are some elements in the codomain, but there are elements that are inside the codomain, but they are not part of the range, that are not outputs for any inputs. So in this case, we will call this into. So it is going inside, the whole A is going inside B. What is onto? Onto is the opposite. So each sort of output will have some input. So some input, all the elements in the codomain, are outputs of some input. If that is the case, so if all the elements in A, say all the elements in B, this is the codomain, if they have some sort of input, if they have some input here, so that is not possible. Let me just try it one more. Yeah, so if all the outputs have some input, then we will call it a onto function, because it is mapping 1 1 and onto. So essentially like that. Then comes even versus odd functions. The concept is very simple. It becomes much more clearer by the use of a graph. So what we do is, if a function is even, then whether you put the value of x as positive x or whether you put the value of x as the negative of x, the output comes out to be the same. So we consider a parabola. Parabola is essentially an even function, an example of even function. Why? Because if you replace the value of x, which was say 5, so if you put x equals 5, and then if you put x equals minus 5, the output will be the same. If that happens, then the function is considered an even function. Whereas an odd function is not the opposite of that. It's not like any function is either an even function or an odd function. No, there are functions that are even functions, there are functions that are odd functions, and there are functions that are not even and not odd, right? So for an even functions, the definition is f of minus x is equal to f of x. For an odd function, the definition is f of minus x is equal to minus of fx. So as the input becomes negative, the output becomes negative as well. But otherwise, the structure is symmetrical. So in the towards the positive side, the structure is symmetrical. Towards the negative side, the structure is the same, just flipped. That is an odd function. So there are odd functions, there are even functions, there are functions that are not even, not odd, and this is the definition of even and odd functions. And I hope this is clear. Let me check if you have any doubts. I don't think so. So in graphical transformation, can you show the last line? Graphical transformation. Okay. So this is the graphical transformation. The last line says f of a times x. So this part is not visible, right? The first part, f of a times x is equal to this kind of, if we do this, if we multiply the input by a, then this is called as the horizontal compression. Horizontal compression, we are horizontally compressing it. This, what happens is, it speeds up or slows down the graph's response compressed if a is stretched to 0, a is less than 0, a is greater than 0, less than 1. So what happens is that, consider this is the graph. Consider you are defining it as fx is equal to x square or something like that. So this is the graph like that. If you multiply it by ax, what will happen? It will be a square x square. So the output is suddenly increased, right, for the same value of x if a is greater than 1. So the new graph will be something like this, because it will increase very rapidly, because you have multiplied a number that is greater than 1. So the value will increase very rapidly as compared to before. So it will be squeezed. On the other hand, if the value of a, if it is less than 1 but greater than 0, then it will be slightly broadened. Why? Because you will be multiplying by a number that is less than 1. So it has to be slightly broadened, right? It will be broadened and it will look like this. So this is the last line. I hope it is clear now. Let's look at. So this was the character of function, 1 1 versus many 1, onto versus into, and even versus odd. Let's now discuss inverse functions. So I'm pretty sure you are familiar with inverse functions. What exactly is an inverse function? So consider fx is equal to the usual x square. So fx is equal to x square is a function. Now if you are slightly experimental enough, what you might do is that you take this function, which is fx is equal to x square, and you try to sort of play with it. You will realize that you need some sort of definition to actually write a way in which we can take the output and get the input, right? Because if we are going from the input to output, we also want to we might sometimes need to go from output to the input. So an inverse of a function takes us from the output to the input. How? An inverse of the function will take the input as the output of the original function, and as the output it will give the input of the original function, right? So for example, an inverse is denoted by f of minus 1 x, f inverse x. This is how we denote the inverse of a function fx. So inverse of fx is denoted as f inverse x. This is how you denote it. So inverse of fx is denoted as f inverse x. What does it do? If you put the input as the output of the original function, so output of the original function was fx, remember, x was the input, fx was the output. If you make this the input in the new function, which is f of inverse of x, then this will give you x. This will give you the original input where we started. So you take the starting input, you put it in fx, it will give you the output fx. If you take this fx, this output, and put it in the inverse function, this inverse function gives you the original number. So that is what an inverse function is. So can any of you guess what is the inverse function of fx is equal to x square? Well, it is simply f inverse of x is equal to plus or minus the square root of x. This is how we will define it, right? It can be positive, it can be negative. There are two outputs. Again, if there are two outputs, we are defining it f inverse of x like that. It might not be a function, right, in the way I have written it, but you get the idea, right? We are getting we are putting either plus x or minus x, we are getting the output as x squared. If we want to define an inverse, we have to take the square root of x. If you want to define the whole inverse, if you want to take all the possibilities, then you have to consider plus x, plus of the square root of x, and minus of the square root of x. Okay, so this is the definition. F of inverse of fx is equal to x, and f of inverse of x is also equal to x. Let's move ahead to the next slide. Now there are something called as functional equations. So let me see if you have any doubts. Okay, so functional equations. What exactly is a functional equation? So firstly, we all know what equation is, right? An equation is something like an expression basically. So this will be something k, and this is mx plus b equals k, something like that. This is an equation. Sometimes we are defining equations in which the functions themselves become variables. So I can define an equation where f of x plus f of y is equal to f of x y. This is an equation, right? It tells us that there are some functions that satisfy this criteria, that that if you take one input, the output of one input, if you take the output of another input, then that is equal to the output of the product of those two inputs. There are some functions that might satisfy this criteria, right? And we need to find those functions, right? So this is called as a functional equation. It establishes a certain kind of relationship between a certain number of functions, or if, it might be just one function. We are writing it something about it, and you have to sort of determine what function it can be, right? So that is something that becomes very puzzling, and it repeats in exam. These kind of problems come in exam very frequently, so these are very important. Therefore, we will look at Cauchy's functional equations. What are Cauchy's functional equations? So consider the first equation. F of x plus y is equal to fx plus fy. If you see something like this, you should instantly recognize that this is satisfied by fx equals kx. So fx equals kx, which is a linear function that has no constant term. It has some coefficient of x, we don't know, but these kind of functions in which fx is a linear function, no constant term, multiplied by k, if some these kind of functions will always satisfy fx plus y is equal to fx plus fy, always satisfy. Then comes fx plus y is equal to fx times fy. If you see an equation like this, you should instantly recognize that fx is equal to k raised to the power of x, where k is some constant, will always satisfy this equation. You can take a screenshot of this if you want, but these are very important equations, and you should remember them, right? Whenever you see something like this, you should instantly recognize that, okay, this kind of function will satisfy this kind of function will satisfy this, and then taking that function into mind, you should solve the question. Okay, so these are very important. These are known as Cauchy's functional equations. Then comes f of x times y. If you see something like this, and that is shown as equal to fx plus fy, then this will be satisfied by f of x is equal to log of x base b. This is log of x base b for some constant b. We don't know the constant b. It might change from question to question, problem to problem, equation to equation, but essentially this is the kind of function that will satisfy this functional equation. F of x times y is equal to fx plus fy, because we know that log of x, log base b of any argument x times y is equal to log of base b x plus log of base b y. Since log satisfies this kind of equation, the log function also satisfies fxy is equal to fx plus fy. Okay, lastly we have f of x times y is equal to fx times fy. This is satisfied by x raised to r, because if you consider x raised to k, or if you consider, for example, f of x is equal to x raised to power r, if a function like this is given, then f of k will be x raised to power k, f of m will be x raised to power m, so f of km will be equal to x raised to the power of km, right? So if something like this is given, and if you were to write f of k times m, what will this come out? According to this equation, this will give you x times x raised to the power km. So if you multiply these two, the exponent will be k plus m, right? Is this correct? Wait, f of x times y is equal to fx times fy is satisfied by fx is equal to x raised to the power r for some constant r. Yes, so this is x raised to the power of x, or this is y. Okay, wait, I just confused myself. So this is nothing but f of xy if this is given such that fx, this is equal to fx times fy. If this is given, then this is satisfied by fx is equal to x raised to the power r for some constant r. That constant r can be anything. But if you see how is this satisfied exactly, so consider f of k. This will be k raised to the power of r. F of m will be m raised to the power of r. And f of km will be km raised to the power of r. Now if you multiply these two, k raised to the power of r times m raised to the power of r. If you multiply fk times fm, you will get k raised to the power of r times m raised to the power of r, which is nothing but km raised to the power of r, km whole raised to the power of r. So if this kind of equation you see, it is always satisfied by fx is equal to x raised to the power of r for some constant r. So these are very important equations. These are known as Cauchy's functional equations. I hope you understood. Let's move ahead to the next one. So this is the question. I am giving you 60 seconds. That is not much time to solve, but try to solve this question in 60 seconds. If you want to answer these questions yourself, you shouldn't be sitting there, right? You actually can click on options. You can go to cracku.in/live. And you can actually attempt these questions. You can go to this website, cracku.in/live. You might have to log in first, but you can basically go here and you can attempt these questions. I will give you these questions. You can answer them by clicking and submitting your answers. Okay, so it will show up in my leaderboard. I will be able to see who has answered it, who has not been able to answer it, and so on. So you can do this. Okay, cracku.in/live if you wish to do. Okay, I think the time is over. Let's try to solve the question. So what is the question asking? The question asks, let A and B be two sets such that the Cartesian product A cross B consists of 4 elements. If 2 elements of A times B are 1, 4 and 4, 1, then we need to find which of these is true. So consider A as a set and consider B as a set. What exactly is a Cartesian product? Cartesian product will take all the possible elements from A. It will take all the possible elements from B. It will try to sort of form a pair. where A comes here, B comes here, such that A and B, sort of not A and B, A belongs to A and B belongs to B. This is what this is how we define a Cartesian product. We take the elements A from A, we take the elements B from B, we try to make as many pairs as possible. In fact, all the pairs that are possible, right? That is defined as, that is referred to as a Cartesian product. Now we understand that we are taking the Cartesian product A cross B. So whatever will come in this set, so this will be a set like this. This will be an element A from A, an element B from B, right? And this is how we will define this Cartesian product. Now, if this is how we will define this Cartesian product, this means that the first elements are from A, the second element are from B. So we understand that the first element, which is 1 and 4 in these two possibilities, so these are two elements that are given to us. The first sort of terms are 1 and 4. So A must have 1 and 4. Otherwise, where did these 1 and 4 come? Right? These first terms in each of these pairs have to be coming from the set A. And there might be some other terms, we don't know. We don't know about the other terms, but 1 and 4 are definitely there. Then comes B. Similarly, there are 4 and 1 in B. So the 1 and 4 are there in B definitely. We don't know about other terms. We don't know about other terms, but 1 and 4 are definitely there. Now we know that the number of elements in the Cartesian product of two sets. This is the cardinality. Cardinality is nothing but number of elements in a set. So number of elements in this set, in the set of Cartesian product A cross B, the number of elements are given by number of elements in A multiplied by number of elements in B. This is how we calculate the cardinality of A cross B. Now think about it. Let's say A has 1 and 4 as elements and some other elements are there, like let's say there are m number of elements. There are m extra elements there. Let's say there are n extra element in set B. So m extra elements apart from 1 and 4 and n extra elements apart from 1 and 4 in A and B respectively. So what is the cardinality A cross B? The cardinality of A cross B will be the number of elements in set A, which is m plus 2, right? This is m plus 2 times the number of elements in set B, which is n plus 2. This will come out to be, now the cardinality of this sets is given as 4 elements. A cross B consists of 4 elements. So the cardinality is already given as 4. The cardinality is given as 4. This will be m times n is mn plus 2m plus 2n plus 2 times 2 is 4. This will be 4 and 4 will be cancelled. So mn plus 2m plus 2n equals 0. Now we understand that m and n are the number of elements in each of these sets, the number of extra elements in each of these sets. These are the number of extra elements in these sets. This means m and n can be whole numbers. They cannot be negative numbers. They cannot be decimal numbers. They have to be whole numbers. So how is this possible? Mn plus 2m plus 2n equals 0. This is only possible when this is 0, this is 0, this is 0. This means m is equal to 0 and n is equal to 0. This is only possible when this is the case. Therefore, there are no extra elements. So A only has the elements 1 and 4 and B only has the elements 1 and 4. This means A is equal to B. The two sets are equal. If the two sets are equal, then A cross B will be equal to B cross A. That's it. That's our answer. We discussed this when we were discussing about Cartesian product. That Cartesian product A cross B is not equal to B cross A unless A is equal to B. Here we found that A is equal to B. And you don't need to solve this much. This is unnecessary solution, right? You can instantly recognize that 1 and 4 has to be, if there are 4 elements and there is 4 times 1 or 2 times 2 or 1 times 4, that's only possible. But here we are told that there are 1 and 4 in A, 1 and 4 in B. So two elements each are both in A and in B. So there are at least 2 elements in both. So there is only one possibility, 2 times 2. This means there are 2 elements here, 2 elements here. So this is only possible when 1 4 1 4 is the case. If 1 4 and 1 4 is the case, then A and B are equal sets. If they are equal sets, then their Cartesian products, which is A cross B, is equal to B cross A. So this is a simple question, not very hard. I hope you understood Cartesian product and how do we solve problems about that are related to that. Let's move ahead with the next question. So you have 1 minute and 30 seconds to solve this question. You can attempt this question if you want to by going on cracku.in/live. Or if you don't want to do that, just attempt it here. Try to answer in the YouTube chat box and we will see. This is again a very simple question. Okay, I think the time is over. Let's try to solve this question. We are told that there's a set called A is equal to 1, 2, 3. It has the elements 1, 2, 3. B has the elements A, B. We are asked, assuming all relations from set A to set B are equally likely, what is the probability that a relation from A to B is also a function? So a relation can be any subset of the Cartesian product. So if we are talking about any relation whatsoever, then let's just take the Cartesian product of A and B, right? So there are 3 elements here, 2 elements here. Since a relation need not actually take a particular value, it is possible that the relation is not taking any value, right? There might be a case where this is not mapping, the element 1 from A is not mapping to any output from B. If that is the case, then there are 4 possible outputs. The output can be, if this is the input, if this is the output, right, set A to set B. So we are defining set A to set B. This means that A is the input and B is the output. So if this is the case, then the possible outputs can be A, B, A and B both for a particular sort of input, or nothing. So there are 4 possible outputs for each of these, right? For each of these inputs, there are 4 possible outputs. This means number of relations, possible relations. How many number of relations are possible? There are 4 times 4 times 4, because there are 4 possibilities for the first element, 4 possibilities for the second element, 4 possibilities for the third element. This is nothing but 2 squared times 2 squared times 2 squared, which is 2 raised to the power 6. This is the total number of relations. But when we are talking about functions means that one input can only take one output. It cannot take both outputs. So for example, take 1. It can take A output, or it can take B output, or it can take nothing. But it can never take A and B both. It can never take A and B both. So there are 3 possibilities for the first one, right? So let's say, right? So it can take A, B or nothing. The second one can take A, B or nothing. The third one can take A, B or nothing. So this is how we will define a function, but it will never be able to take both, right? So if we need to define a relation from A to B that is also a function. So what are the different possible combinations? We can have 1A, we can have 1B. We can have 1 is not defined on anything, right? We can have 2A, we can have 2B, we can have 2 not defined on anything. We can have 3A, we can have 3B, we can have 3 not defined on anything, right? But again, we are told that what is the probability that a relation from A to B is also a function. So relation is also a function. If that is the case, then how many possibilities are there for the relation to be a function? There are exactly two cube possibilities, right? A function can either take a as output, an input can either take a as output, or it can take b as output. So there are number of functions are 2 cubed. There are 2 cubed number of functions, and the total number of relations are 2 raised to the power of 6. Since that is the case, then the probability p will be nothing but 2 raised to the power 3, which is the number of favorable outcomes, divided by the 2 raised to the power 6, which is the number of total outcomes. This will come out to be p is equal to 1 over 2 cubed, which is 1 over 8. The correct answer is option B. Okay, let's try to solve the next one. Alok is asking, sir, why is it taking A and B both? A and B both can be taken because firstly we are counting how many relations are there. So when we are talking about relations, there is no restriction that there can only be one output. Function has that restriction. Relation does not have that restriction. So since relation does not have that restriction, we can take no output, one output, and two outputs. So 0, 1, 2. So 0, A, B, and A, B, all four are the possibilities when we are talking about relations. But when we are talking about functions, that is not really the case, right? So in this one, the time is over. Okay, why did I post another question? Okay, try to solve this one as well. Then we will discuss the solution for both of them. Okay. A16. Yeah, I think that is correct. 16 is the correct answer. Okay, time over. Let's solve this and then we will solve the previous question. Okay, so here we are asked fx is equal to x square plus log 3x and gy is equal to 2y plus fy. The value of g3 is what we need to find. So the value of g3 will be nothing but 2 times 3, which is 2 times y, plus f of 3. Everything is clear, but we don't know the value of f of 3. So for that we can use the definition of fx. So f of x is equal to x square plus log 3x. This means f of 3 is equal to 3 squared plus log 3 of 3. This means 3 squared is nothing but 9 plus log 3 of 3 is nothing but 1, right? This is 10. So this will be 2 times 3, which is 6, plus 10. Correct answer is 16, which is option A, right? And what about this one? This one I hope you have solved. It was a pretty simple question, right? We are asked fx is equal to x over the modulus of x. X is not equal to 0. Why is x not equal to 0? Because x is in the denominator. It cannot be equal to 0. If that is the case, then essentially for mod x there are only two possibilities. The two possibilities are x is either greater than 0 or x is less than 0. If x is greater than 0, then fx comes out to be x over x. If x is less than 0, then fx comes out to be x over minus x. If this is the case, this is nothing but 1. If this is the case, this is nothing but minus 1. So the only possible outputs are 1 and minus 1. So the outputs are only 1 and minus 1. Therefore, the range is 1 minus 1. This is the set. This is not an interval. This is a set. The set of 1 and minus 1. These are the only two possibilities. Therefore, option B is the correct answer. Another simple question, right? So these two questions were both simple. Okay, so let's do one more fun one. So I think this is a very conceptual question. It's based on concept. If you know about it, you should be able to answer it. Alok says B. Try to see. I think you are talking about the first question, right? Yeah, for the first question, B is the correct answer. Try to solve this one. Okay, I think the time is up. So we all know what log A is, right? So for any number k, that is the argument is k, the base is a. We already know that there is a property that if a is less than 1 but greater than 0, it has to be greater than 0, the base has to be greater than 0. Base cannot be equal to 1. So if the base lies between 0 and 1, say 1 by 2, 1 by 2 lies between 0 and 1. We know that when we raise this to power of 2, what comes out? 1 by 4 comes out, right? 1 by 2 squared is 1 by 4. Now tell me, is 1 by 2 greater than 1 by 4 or less than 1 by 4? 1 by 2 is greater than 1 by 4. So as we are raising 1 by 2 to higher and higher powers, the result that comes out is lower and lower. So if this is the case, if a lies between 0 and 1, then the power as log of a or log a of k, which is the power, this power, as this power increases, the value of k decreases. Right? And we also know that if a is greater than 1, for example 2, 3, 4, as you increase the power, the result will increase. So 2 squared is 4, but 2 cube is 8, and 2 raised to the power of 4 is 16, and so on. So when this happens, then k increases as log a of k, which is the power, increases. So if this is the case, then if log ak increases, then k decreases. If log ak increases, then k increases. When in this case, if a is greater than 1, then this happens. If a is less than 1 but greater than 0, then this happens. Okay, so based on this, fx is greater than gx. If this is given, that log of a of fx is less than log of a of gx, if this is given to us, then either fx is less than gx. When will fx is less than gx be? Fx will be less than gx when this a is greater than 1, right? If it is greater than 1, then basically this power, as power increase, the whole function will decrease. The whole function will decrease as power increases, right? So this function will decrease as power increases. So if this is already less than 1, less than gx, log of a of gx, if the power this side is less than this, the power this side, then based on this condition, the input, the argument this side will be greater, the argument this side will be lesser. So if fx is greater than gx is greater than 0, if this is the case, if fx is greater than gx, then a has to be less than 1. If fx is less than gx, then a has to be greater than 1, right? Based on these conditions. So option A is the correct answer, right? Based on these conditions. I hope you already understand these conditions, right? Because consider the number 1 by 2, as we just discussed. It lies between 0 and 1. As we increase the power of 1 by 2, say 3, 4, 5, 6, and so on, the value of the whole decreases. 1 by 2 raised to the power of 1 is 1 by 2. 2 raised to the power of 2 is 1 by 4, which decreased. 1 by 8 is further decreased, right? So whenever a number is between 0 and 1, as we increase the power, the output actually decreases. This is the whole concept behind logs, right? So let's do the next question. I hope this was clear. If you have any doubts, just post them in the chat box. This is a more like serious question, right? I will give you more time if you need, but I want you to solve this and I want you to answer it. Okay. Alokas, can you please explain this relating to the basics? Okay, we'll solve this question and we'll go back to that question. Okay, we'll discuss that question again. Okay, I think the time is over. Let's try to solve this question. We have the function fx is equal to x cube minus f5x squared minus 8x divided by 3. We need to find how does the graph look like. First we will draw the graph and then we will try to answer the questions. Okay, so we have the numerator x cube minus 5x squared minus 8x divided by 3. This is the numerator and this is the denominator fx. Now I can write it as x times, so I will take x common, I will write x squared minus 5x minus 8 divided by 3, right? What does this mean? This means that x is equal to 0 is a root of this equation, right? If we put x is equal to 0, the function will become 0 because the numerator will become 0. So if we put x is equal to 0, that is a root of this function. So if I need to look at the graph of this function, for example, so let me draw the graph here. So let's say this is the graph, right? So x and y axes, then say this is 0. So for 0, x is equal to 0, the value of the function is 0. Now look at this quadratic inside. This quadratic inside, this will also have some zeros, right? This will also have some roots. So what are those roots? So let's try to apply the quadratic formula to find the roots of this quadratic equation that is inside the bracket. How will we find it? The quadratic formula says minus b plus minus b squared minus 4ac square root divided by 2a. So this will be minus b, which is 5, plus minus b squared, which is 25, minus 4ac, which is plus 32, divided by 2a, which is 2. So the roots are 5 plus minus square root of 57 divided by 2. So these are the roots. We don't know the square root of 57, but we know that it is around 7 point something, because 7 squared is 49, 8 squared is 64, so it is 7 point something. We don't know. but we know that it is almost right 7.5, right? So let's just do the rough calculation here. The first root will be 5 plus 7.5 divided by 2, almost equal to almost close to 5 plus 7.5 divided by 2, and the second root will be almost close to 5 minus 7.5 divided by 2. This will be what, 12.5, which is 6 point something, 6.2 maybe. This will be around 5 minus 7.5, which is minus 2.5 divided by 2, which is minus 1 point something, minus 1.5, let's say. So the first root will lie somewhere over here, minus 1, close to minus 1, very close to minus 1. The second one will lie somewhere close to minus 7, because it is minus 6, not minus 7, plus 7, right? This is plus 7, right? So now think about it. Now what kind of function is this in the numerator? It is a cubic function. So how many roots it has? 3 roots. We found those 3 roots. The first root is minus 5, 5 plus minus square root of 57 divided by 2. The second root is 5 minus 7.5 or square root of 57 divided by 2. These are the 2 roots, and the other root is 0. These are the 3 roots. We needed 3 roots, we found the 3 roots. Now think about it. We need to draw the graph of this equation, this function, to actually understand what is going on. So how do we draw the graph? Well, first take any number beyond 7, greater than 7. Let's say 8. We'll take 8. All we need to look at is whether the function is positive at 8 or negative at 8. Let's just look at that. So 8 cubed is 512, minus 8 squared is 64, times 5 is 320. 512 minus 320 minus 8 is a 64. So that is 384. 512 minus 384 divided by 3, that is a positive number. So basically all we know is that here it is positive. The graph is positive after 7, or after this 0, not 7, after the biggest 0, the biggest root of this whole function. Then it will become negative, because we know that at the point of the root the graph will change its sign. Then it will go until here, until 0. It will again become positive for some time, and then it will again become negative. So this is how the graph will look like. It will be positive beyond the largest root. Between 0 and the largest root it will be negative. Between 0 and the smallest root it will be